Hi, my name's Brent Harris. I'm the Chief Operating Officer at Eguana Technologies in Calgary. We're building grid modernization solutions for the grid edge based on residential energy storage. Not a lot has changed in the electricity value chain in the last 100 years. We're starting to see the beginnings of some changes now. The utility industry generally has been built on an asset-based model where utilities build a new infrastructure, transmission, distribution, and generation, and then charge the cost over time by setting electricity rates for ratepayers. The cost would be shared appropriately among all the ratepayers. If Thomas Edison were to come back from the dead today and look at our electricity system, you wouldn't see anything he didn't recognize. It really hasn't changed a lot. The big changes in the value chain as it's defined for electricity is in who are customers and who are producers and what interactions are going. So from the very beginning, it was one-way interaction between large companies or government organizations that were building out this infrastructure and then dealing directly with the customers. And you'd have a monopoly on that relationship. It was not practical for a long period of time for anybody to generate their own electricity. In the 1970s and 80s, you started to see deregulation of the electricity system and independent generators coming in and being able to do different things, do combined heat and power, do gas turbines and small run-of-the-river hydro. So you started to see the utility give up some of that monopoly control and say, okay, we're going to buy electricity from these other producers and there'd be a cost of electricity determined. So things got a little bit more complex. Through the 1980s and 90s, there started to be more of a push for clean electricity, which is pushing toward nuclear and then renewables. And at the beginning of that, wind power was seen as the best way to build out large-scale renewables, and that solar would be a distributed technology that would go more toward the end users and even be owned and operated by the end users. In the end, financial considerations took over to an extent that I don't think the original developers of the solar technology appreciated, and drove everything to large-scale projects because it's far easier to raise capital and develop a large project and then sell it on to a project owner. That project financial model took over from the superior economics for putting solar next to where it's used because all the regulatory change that would have to come with it as well. So through the 80s and 90s, we saw growth in renewables. We followed advice from a gentleman named Amory Lovins, who founded the Rocky Mountain Institute, and he started talking about the problems with centralized power in the 1980s and wrote a book called Brittle Power, and was just more the resiliency of this electricity system that's based on ever larger power generation sites and ever longer transmission and distribution lines to bring them energy to where it's needed was too fragile, subject to sudden failures of components that would take out large amounts of electricity, vulnerable to attacks, vulnerable to storms that we've seen, like what's gone on in Texas recently. So all of this was predicted, and looking more to a Japanese model where you had a far higher number of smaller systems distributed throughout the electricity grid to get resiliency. So we saw that change happening. That's when we founded the company around the turn of the millennium. I think the interesting thing that we've noted recently is that progress stalled around that time on restructuring how the electricity system worked because you had renewable energy coming in at the distributed level, but especially electrical efficiency. So switching to LED lights, like first CFLs, then LEDs, switching to more efficient HVAC systems, all kinds of efficiency gains helped keep the peak load down on the grid. And the grid is really not built to deliver energy, it's built to deliver power. So it's designed for the peak load, even if that only happens for a few hours a year. That's what you're designing for. And as the efficiency came in, it held back the growth of that peak load. So it took the pressure off changes to the electricity system. What we've seen now through the past few years is those efficiency gains have been achieved. It's hard to find anybody using anything but LED lights anymore. All our computer systems, data centers, power supplies, HVAC systems, everything's been optimized and the efficiencies there. So now as you get more of those on the grid, the load is going up again. But especially electric vehicles coming on the grid is shifting a lot of the primary or secondary energy use from fossil fuels going into vehicles. Now that's all being drawn through the grid and generated in different ways. The role decentralized energy is playing is in mitigating that peak load growth and deferring investments and expansion of linear infrastructure like transmission and distribution, which is expensive and increasingly almost impossible to do. To get more access to more land, to put more transmission systems in is not an easy task. Nobody wants to give the land up for that purpose. So we've got to make better use of the infrastructure we have by putting smarter devices out there. And that's what decentralized energy is and what it does fundamentally is increase the utilization rate of our existing infrastructure instead of having it idle for long periods of time and then hitting these peaks. If you can shift the usage around with storage and with other technologies, you can start to bring the average load on our infrastructure closer to the peak load, and that's more effective use of our assets. In terms of global energy markets, we've seen on a national basis, Australia is the most advanced in this. Australia is actually planning decentralized energy primarily in the form of solar and battery systems at the residential and commercial level, forecasting those into their integrated resource planning and expecting them to be there to meet certain needs in the future. And so they're not planning other investments for that. If you look almost anywhere else in the world, decentralized energy, the benefits are understood, but they're not necessarily trusted and they're not put into the. So we'll do some pilots and we'll get this out there and see what it does. But I know it's probably going to bring this peak down, but we're still going to build this gas turbine anyway because we can't rely on this decentralized energy to do that. So they crossed that bridge in Australia. They're planning the reliability of their future energy grid on decentralized energy being there and delivering the value. And that's fundamentally the change that needs to happen everywhere to bring this forward and get the benefits. If you're still investing in the same old stuff, now all you've done is increase your cost. I think the value chain is going to change now as this peak load is growing. People have been thinking about this for 20 years now since the problem became less urgent. And now it's urgent again. There's a lot more thinking that's gone on, and you're just going to see a more transactional based electricity system. And you're going to see, instead of one way customer supplier transactions, it's going to go both ways. I don't believe we're going to see a peer-to-peer energy system where you're trading energy with your neighbor. I think it's all going to go through a system operator the same way it does today. It's going to get more complex. I think the peer-to-peer is working on the information technology side because there's not this balancing work that needs to be done, but a power grid stability depends on balancing supply and demand. I just don't see how we get there with millions of people trading energy with their neighbors and that coming to a result that's going to avoid the grid collapsing. But somebody needs to be in charge of that. Right now, they tend to be the people that own the assets, but I think you're going to see a decoupling of that where there's a group that's in charge of running the system. And then there are lots of different parties that are building these assets and infrastructure that go in depending on where you are and who needs what. The main benefit of decentralized energy is its flexibility and modularity. Uh, and then putting the supply close to the demand. The big change, everybody thinks of it in terms of the power grid, which there's the benefit there that we're not occupying capacity on this transmission line, moving energy from thousands of kilometers away to turn somebody's lights on. You've got generation at the facility, or you've got storage at the facility, but bring energy in at a lower peak time and then use it during peak period. It has benefits there, as I've said, in increasing the utilization rate of the infrastructure. But the other benefit that comes with it that I think is often overlooked is just the supply chain and the value chain and how this is delivered. If you look at utility planning, they are planning generally on a 5 to 10 year horizon, and they've got these big projects with big engineering companies and lots of accountants and lawyers, and it's big project-based economics. And yeah, okay, this is our load forecast, and we know it takes 10 years or 15 years to get a dam built. Let's say northern BC right now with Site C, and it just takes all this capital and time, and bang, suddenly you're getting shortage, and now you've got this huge new asset. And now at the beginning, it's not really even used that well. Maybe the world didn't turn out the way you thought it was going to 10 or 15 years ago, and this isn't the right place for electricity. The price you're able to sell the electricity for isn't what you expected. It brings all that uncertainty in. What decentralized energy does is move to a more trades and manufacturing approach, where now you're building smaller devices, products, essentially on a production line where you're getting economies of scale over time as the industry grows. Your costs are coming down, and you're using trades to put them in, electricians primarily. So you're taking advantage of the labor force that's out there and available and having them install these products in the more repeatable process. Each year, you're installing the latest technology for that year. You're not installing something that was designed 10 or 15 years ago. If the world changes from your expectations, you just shift the location or the type and size of technology you're installing, and you adapt in real time, and you can follow with small incremental steps, keeping up with the demand and following those turns as the unexpected happens over that period of time. So it's a big change in thinking of how to build the infrastructure. It's more of a flow thinking, manufacturing and trades, and let's get out there. How many megawatts did we install this month versus how's that project coming along? That's the big change to the value chain that comes along. And the benefits are having current technology, having demand better matched to load, and ultimately it's lower costs for energy for society. It's cleaner energy for society when we're more flexible that way. On the reliability side, going back to that concept of brittle power, by putting these systems in the grid close to where the power is used, you get a lot more options of how to respond to outages, how to deal with planned outages. The grid just becomes a lot more flexible and dynamic. Ultimately, if we get enough decentralized energy out there, you can island parts of the grid and make them microgrids during periods of disruption. And ultimately, that's the vision. Each part of the grid is going to be self-sufficient and be able to operate on its own or at higher efficiency by interconnecting with the other microgrids around. I think the business models are changing right now, and not a lot of that is flowing through to the end customer right away. I think there's been some attempts to do that, but fundamentally, there's a drive out there to say, let's make this a market economy. And if we set our prices right for the right things, then people will make buying decisions according to those prices. I think one of the things everybody's learning is this is a big challenge in electricity because most people can't even tell you what they pay for electricity or how it's priced or what they could do to reduce their power bill other than turn the lights off when they leave the room. So it's a pretty tough challenge just because people are not listening. There's a Spanish company putting a change in Spain, so they're going to have a day-ahead forecast hour by hour for electricity price, and it's going to be published in the newspaper in the morning, and everybody can read the newspaper and then decide how they're going to schedule their day. I don't think anybody's really going to do that. So it's a challenge to bring it through and manage end customer use, other than very simple ideas like time of use has some impact. What you are seeing in the business models is going to be competitive markets to more and more jurisdictions where you separate the role of generation and retailing electricity, and then from the role of the wires owner. You are seeing changes being driven now because of energy storage. So most jurisdictions classify an entity that's connected to the grid. You're either a generator or you're a customer. And they've segmented those into different buckets. And the way the regulations work, it's not easy to cross that bridge. When you operate the storage system, you have the ability to be both. So we see the problem at the bulk level, large scale storage systems alongside generation, where they're potentially could bring power in and charge the battery at times of low price and discharge at a high price if they're not managing the generation. They get billed today as if they're both a customer and a generator, so they pay the admin fee twice. At the residential level, it's basically leaning back on the net metering and saying you can't export power out of this site, where sometimes it may make sense to discharge the battery to support the grid. So those are the regulatory models. I think probably the biggest change is around energy storage and how it's treated in order that the grid and society in general can get the benefit out of the storage systems without these artificial barriers. Like I said, there hasn't been a lot of motivation to upgrade the grid for the last couple of decades. It needs to be updated and replaced. And there's uncertainty around the right way to do it. So we need to understand what we're doing, understand we can rely on decentralized energy to solve these problems and start deploying it. Like I said, it's modular. We can start rolling it out right now. And as the fleet grows, you'll get more benefits and you can validate it. And it doesn't require a massive commitment of billions of dollars to do that, where most traditional infrastructure upgrades are like that. They're this big on switch to approving billions of dollars. And if you don't do the whole thing, you don't get any value out of it. In terms of energy security, I think we're just seeing more reliance on these long transmission lines for reliability is a bad bet. Even to the point, I think it's been brought home most effectively in California, where you have distribution utilities and transmission utilities that have been held liable for wildfires caused by their power lines going down during high wind periods. So these companies have now been held liable, and their response to that is saying, we have a responsibility to provide power to customers for society, but we also have a responsibility to stop wildfires. So what we're going to do is called a public safety power shutdown, PSPS, in California. And when they see high wind days, they just shut everybody's power off. If the line comes down, it's not powered, so it's not going to cause any fires. That is somewhat reasonable, but there may be ways to reinforce that infrastructure. But perhaps we should just be looking at future infrastructure investments working around that. And it's like, that's great. We've got these transmission interties. We could share power most of the time between regions, but what we need to do now is make sure each section is resilient on its own, and we need to get our resiliency from local resources instead of depending on this dangerous power line to stay running. And that may be a regional thing, but we're seeing it more even in British Columbia and other places where wildfires are prevalent. Downed power infrastructure is a major cause to start these fires. I think it was the PERPA Act, the PRA in the late 70s, early 80s that started that for us. Certainly the signing of the Kyoto Protocol in 1998 kind of clarified a lot of the ideas that had been brewing around how to deal with greenhouse gases and all of that. And we saw that creating an opportunity to look at the electricity grid in a different way. Around the late 90s, early 2000s, you had a lot of innovations in power electronics and transistors for power electronics that, made things a lot more practical, a lot more efficient, and made power electronics viable for widespread deployment as a grid asset. At the same time, you had advanced digital signal processing and microprocessors. There was a huge leap forward. So I think if you look at the technologies that are out there today for power electronics, they'll almost all had an inflection point in the late 90s and early 2000s. And then around that time, we didn't see the full effects till about 10 years later, but you had the internet building. So when we first integrated our electronics for fuel cell systems around 2000, and we were looking at standard like modem-based communication technologies, trying to work through the metering infrastructure, communication, and utility SCADA, the advances in the internet, and then moving to the Internet of Things, and now highly secure, fast, and low-cost communications have really changed everything for how the options for decentralized energy can be so much faster now and so much more responsive. They can frame it right to one decision by Toyota and their Prius hybrid vehicle when they switched from nickel metal hydride batteries to lithium ion batteries in 2008 and said, this is the battery of the future. I think a lot of other companies were making similar decisions around that time, but that was certainly the most public. And there's been no looking back since then. Lithium-ion batteries were developed in the 1990s and originally used just for portable electronics, really ramped up with the iPhone. And then once the electric vehicle manufacturers said we're switching to this technology, that kind of set the stage and the path for the cost reductions we saw. And that's why you see so many lithium battery products, because of the cost reduction that was triggered by the switch in the electric vehicle business to lithium-ion batteries. The choice allowed everybody to focus on that one technology and confidently make those investments to bring the cost down. I think the trades are going to be key to bringing this forward and making sure they're understanding and getting trained on this through their schooling, and that we make the products the right way that the trades can come in and install it and do their business and deploy the infrastructure. So we see that as a key constraint right now. Do we have enough of those trades in place to be able to do that? Homeowners and electricity users in general are key stakeholder. That's the whole reason we're talking about any of this, is people need electricity. As we move to electrification and we start bringing only electricity to homes instead of bringing gas and other energy sources to homes, this resiliency is only getting more critical. If you lose your electricity supply, you can't charge your car either. That's not like you can have some gas in the tank or something else, right? Or in cold climates, it's pretty critical to have that electricity to keep your house warm. So homeowners are valuable. They're going to have to be hosting some of this infrastructure. And like I said, there's going to be this supervisor of the grid, which there is today, but this is becoming a lot more dynamic, and it's going to become a lot more complicated and important. The job going forward is balancing all of this energy. Regulatory changes impact us hugely. It defines where we can operate. We're seeing more interest in what we're doing here in Canada. We're going to do more business domestically in Canada than we have since the Ontario feed-in tariff period and since about 2012. There needs to be change to policy in order to enable solar. And then it's the growth in solar combined with the growth in electric vehicles that generally drives the need for storage. We believe that in order to get storage working the way we want it in the places we want it, it's going to have to be a utility-owned asset where the utility is going to sell resiliency services to the hosts of the systems, as opposed to what they call sometimes bring your own device programs, where a homeowner will buy an asset that gets integrated into the utility demand response control system. the electricity market is different everywhere. It's not really suited to a fully competitive market. Nobody wants to see 2 or 3 different sets of wires running down the street. One set of wires is plenty. So right there, you're saying, okay, we're not going to have a competitive market for transmission and distribution. We're going to have one, and we're going to regulate it. And these all started in different ways in different areas, right? And all kinds of different concerns, and the regulation around those markets built up in different ways on some of the same principles. But what it means is what works well in one place may be totally foreign in another. It takes time to understand, and then it takes time for change to happen, even once the people in those regions understand that there'd be some value in changing and adopting these new technologies and changing the regulation to adopt them. It's critical. It seems like a very fundamental technology, and the physics and the electrical engineering is the same everywhere, but the commercial aspects of it are totally different everywhere, and the regulatory aspects. Demand does go up and down, so we built a fairly flexible supply chain. It's electronics assembly and test, which we use third parties to do that make electronics for lots of different people. They're called electronic contract manufacturers or electronic manufacturing services companies. So we've made an effort to design our products so that they can be built on the standard electronic production lines, and then we don't have to invest in our own machinery for that. That allows us to flex our production up quickly and down quickly should we need to. The main investment we have is in what's called the functional test stand at the end of the production line, where we test every single unit for about 45 minutes before it goes out to customers. It's an automated test, and that is about $250,000 piece of equipment. And so if we saw demand ramp up significantly, we've got lots of room to grow with the infrastructure we have today. But if we're getting into shipping thousands of systems per month, it drives additional investment in those test stands at about $250,000 off and about 4 to 5 months lead time to get it. So if that's our response to it, then we would add more people to support those customers that are buying all those new products and training new installers. If the demand were to increase that much, that would be the biggest challenge, is building that installation capability in those markets where the demand is growing. We generally buy components from suppliers who have a lot of customers in other industries. So we don't see any constraints right now that we have to work through in our supply chain. Well, Eguana Technologies was started to commercialize and deliver this technology of decentralized energy, primarily energy storage systems. We got started in 1998 looking at fuel cell systems. So basically hydrogen storage. We took the technology, first commercialized it, and then licensed it to a large German utility called RWE. And RWE was planning to use hydrogen fuel cells to build decentralized energy infrastructure across Germany through the boiler replacement market. So looking at multi-residential homes, when they needed a new boiler, take out the boiler, put in a fuel cell system instead that would generate the heat required for the building and then electricity as a byproduct that could be managed onto the grid. And they were the utility there at the time. So that was how we first commercialized the technology. We were selling just the power electronics at that time to people that would integrate the decentralized energy systems. What's happened since then is we have integrated the entire technology stack. So we integrate and certify the whole product, and we also have the IoT solution, Internet of Things, that allows all these systems to be networked, and we build the cloud that networks them together and offers them as a fleet to the utility. So that's actually, that last piece is what has come into place for us over the last year and has created a shift in fitting the company of marketing our technologies to people that are putting these systems together to sell them to utilities. We're doing it ourselves now. We've completed the full stack integration of our technology to have our own cloud now that manages our fleet of systems. I love working with the people we have here at Eguana, talking to them about what they're working on and what they've found, new developments, new opportunities they see, just working with everybody and their excitement about what we're doing. And then to extend beyond that, what's really exciting is when you find your way into a utility and you find a kindred spirit there that is interested in making these changes happen, and then trying to find ways to work with them so they can address concerns of the regulator or explain the objectives internally and get the rest of the team at their utility excited and really trying to create that change. That's the exciting part for me, is seeing the change happen and seeing things we've talked about start over a period of a few years. Now everybody's talking about the same things, and you can see some of the influence we've had in the industry to bring that about. The grid of the future that we're building here, modernizing the grid, it's going to result in a far more flexible, adaptable grid than everybody's used to. There is some risk and a lot of change involved in that. You're not building these huge assets anymore. You're deploying devices and interconnecting them and building up a fleet and incrementally building your capacity that way. It's a big shift that needs to happen. There's lots of people inside the utility industry that understand that and know that and are working toward it. And we're here to deliver solutions that are going to help them achieve that, and solutions that are designed for utilities and not just backup power systems for homeowners that they're trying to repurpose to do something for the grid.